Hey guys, today we're going to do battleships in a board, and it's a good question, and I like it a lot, so let's get started. So, given a 2D board, count how many battleships are in it. The battleships are represented by X characters in a string, and empty slots are represented by a period character. You may assume the following rules. You receive a valid board. Battleships can only be placed horizontally or vertically, meaning that you can't have an example like this where they're both horizontal and vertical. And at least one horizontal or vertical cell separates between two battleships. There are no adjacent battleships. Cool. So this is an example battleship, example input. This is one battleship. This is another battleship, 1, 2, 3. So in total, this is two battleships. In this example, this is an invalid board. And so therefore, we can't even go about, solving this problem. This question is just like number of islands, if you've done that question before, where you're given a 2D array where each particular value represents an island, and you have to count how many islands there are. So you can kind of think of it this way, where instead of an island, it's a battleship. But yeah, the basic idea is to iterate over every single item in this 2D array and say, if it's a ship, try to mark all the X values that are connected to that ship as dots, increment your counter by 1, and then continue. And before you know it, you're going to have marked everything as a dot, and you'll have only incremented your counter a few times. So that's what we'll do. Basically, it's a DFS where when you find an X, you say, okay, reach out as many places as I can and mark all the X's that are connected to this X as dots, and then repeat. So that's what we're going to do. So as I always do, return a helper function, self.dfs, let's call it, and count, takes the board, and that's it. Then we have DFS, let's give it self, case the board, right? So now we have a counter, count equals 0. We say for row index, row in enumerate board. So the first layer of the board is a row, and for val index and val in enumerate the row. So for each value, we're doing nested loops here. We're going to say if the value is equal to an X, right? We want to basically look for the surrounding, the connected X's and mark them as periods. So let's do that. So mark self.mark as seen. We're going to pass it the board. We're going to pass it our index of the row and basically our position. So row index and val index. And it's going to actually return the board after it's been modified. And then, since we found an X, we can increment our counter by 1. So let's do that. And then here we'll return our count, and that'll pop back up to this count battleships method and go from there. Now the next part is mark as seen. So define mark as seen, give it self, board, I, j, and what do we want to do? First thing we want to do is create the base case. So the base case is we're going to be changing the I and j, the indices or our coordinates, each time we recurse. And what we're going to do is basically, if we find the next value, we're going to say check the index above it, check the value to the left of it, check the value below it, and check the value to the right of it. However, we have to keep in consideration, the bounds of indices of arrays. So our first base case is going to be if I is less than 0 or j is less than 0, or that's if we're above the board to the left of the board. Now, if we're on the right of the board, we're going to say if I is greater than or equal to the length of the board, or j is greater than or equal to the length of the columns, so it's below the board, or, and this is a good one, is if our value is not an X, right? We don't really care. If it's not an X, we want to mark it as a period, but it's already a period. So we can return our original board, right? Now, if we're in the bounds of the array, and it is an X. Oh, or board does not equal X. So that means it is an X for here now. So we'll say, okay, board of ij is equal to a period. And then we want to recursively call this on all the four dimensions the four directions, sorry, that can possibly have a battleship. So self.mark as seen on the board, I, J, right? And this will return the board. So let's just do that. Board equals, board equals, board equals. I'm doing one for each direction, so up, down, left, and right. And so this will be to the right, this will be to the left, this will be down, and this will be up, and then we'll return the board. And this actually should work just like that. So let's just run it. Cool. So yeah, what we're doing again is for every single value in this 2D array, if there's an X, if it's an X, basically depth first search from that X, finding all the connected X's, mark them as periods. Once that's done and we've returned to our caller, increment the counter because that was one battleship. Do that for every single item in this array and we'll be done. And at the end we return our count and we have the number of battleships. The same exact approach can be used for number of islands and it works. So what are the base cases here? Okay, maybe the board is all X's or all periods, right? So let's do all periods. Let's run it again. Cool. Maybe there is no board, even though we were told it's a valid board. So let's see if this what happens if you have an empty array. 0, cool. And then all X's, we don't have to run right now. So let's submit this and see how it goes. Cool. Not very fast, but it is the way we did it. Thank you for joining. This is a depth first search question. It is a recursive question. And it's very good to know this pattern.